Hello, and welcome to Getting Started with AWS IoT Core for LoRaWAN Network Analyzer. My name is Greg Breen, and I'm an IoT Specialist Solutions Architect with AWS. This video dives straight into the Network Analyzer feature of the AWS IoT Core for LoRaWAN service. To follow along, it's helpful if you're already somewhat familiar with LoRaWAN fundamentals and the AWS IoT Core for LoRaWAN service. Network Analyzer allows you to monitor and debug your fleet by tracing network frames and events in real time. Activity can be traced for both devices and gateways. The user can select the specific device and gateway resources that should be traced, and the user can control the logging level. We'll now learn about the features and capabilities of the AWS IoT Core for LoRaWAN Network Analyzer. Using a Class A device, we will add device and gateway resources to the configuration to select what to trace a device joining the network, trace a device sending uplinks, modify the configuration to control what frames and events are traced, trace downlink messages being sent to a device, and finally, trace a gateway connecting to AWS IoT Core for LoRaWAN. We begin by navigating to the Network Analyzer. Network Analyzer has a default configuration. This has frame info enabled and log level set to info. These are the most verbose trace settings. It has no devices or gateways configured, and hence it will not yet produce any traces. At this time, it's not possible to create your own configuration, so we select this default. Drilling down, we can again see the frame info and the log level settings. Clicking on the Resources tab, we confirm the configuration lacks device or gateway resources, and therefore we need to add some. For the purposes of this demonstration, I'll add just a single gateway and a single Class A device. Returning to the Resources tab, we confirm that the gateway and device have been successfully added. We can now activate trace messaging for these two resources. A short time after powering on the device, we receive 3 trace messages about the device joining the network. There are 2 broad categories of trace messages, and these can be distinguished by the trace columns. The first message is a log event. You can use the configuration's log level to control logging of these events. The second and third messages are LoRaWAN frames. You can use the configuration's frame info setting to control the logging of these. All of these messages originate from the same resource ID, a wireless device ID in this case. Examining the first trace message, we see it's an event that records a successful join. The second trace message is a join request LoRaWAN frame from the device. And the third trace message is a join accept frame sent back to the device. As you can see, the LoRaWAN frame trace message records a great deal of information. It records the gateway that handled the message, the RSSI, SNR, data rate, frequency, and fine details of the LoRaWAN MAC. After a delay, we see the first uplink from the device. Again, we have both a log event for the uplink and also a LoRaWAN frame. We examine the details of the log event to confirm it's an uplink from the device. Likewise, the details of the LoRaWAN frame show that it's an unconfirmed uplink. As before, many details are recorded. We now deactivate the trace session. Then, modify the default configuration to disable the logging of events. Reactivating the trace session and repowering the device, we see it join the network again. However, as expected, this time we have only LoRaWAN frames and no log events. Deactivating the trace again, we'll now look at the converse configuration. we re-enable log events but disable the frame info. Restarting both the trace and the device, we can observe that just the log event for the join is recorded this time and no LoRaWAN frames are in the trace. Now we quickly restore the LoRaWAN frame tracing before proceeding. Activating the trace once more, we repower the device and wait for it to join the network. Before proceeding to downlinks, we pause briefly to await the first uplink. Navigating now to our wireless device in the console, we place a confirmed downlink message into its downlink queue. Returning to the active trace, we await the next uplink. Upon the next uplink, we receive 3 trace messages, 1 uplink log event and 2 LoRaWAN frames. Examining the details, our log event is an uplink. The first LoRaWAN frame is the same unconfirmed uplink. But the second LoRaWAN frame is the confirmed downlink that we queued a short time ago. Notable for its absence, however, is a log event for the downlink. This is because this was a confirmed downlink and AWS IoT Call for LoRaWAN is yet to receive an acknowledgement from the device. Upon the next uplink, we get both a downlink and uplink log event. Drilling into the uplink LoRaWAN frame, we can observe that the acknowledgement was sent, completing the confirmed downlink. We conclude the demonstration by repowering the gateway to force a reconnection. A short time later, several wireless gateway log events are recorded. Inspecting the details, we can see that the reconnection first caused a disconnection, followed shortly thereafter by a successful reconnection. Thank you for watching this video. If you have any questions, please ask them at repost.aws, where you can leverage the entire AWS community. I may see you there. Goodbye for now.